Few important points for us. System of charges will take. Please check it. A positive charge Q. Another negative charge Q of same size. I'm telling you, they are equal and opposite charges. I want to draw the field lines of this system of charges. When I want to do that, I will first select the line joining these two. I will keep the positive charge, small positive charge here. It is repelled by positive charge, attracted by negative charge. Both forces are there in the same direction, because of which it travels straight along this line, moves from positive charge to negative charge. Listen carefully. If I keep the charge anywhere here, what will happen? Charges are of equal magnitude. If I keep the test charge on the line joining these two charges to the left of positive charge, the repulsive force is always greater than the attractive force because it is nearer to positive charge, further from the negative charge. It moves to infinity along the same line of charge. If I keep it at infinity, it comes back to negative charge. Just for the sake of explanation, one or two lines I will talk about and then straight the remaining lines. If I keep a positive charge here, please observe, large, it experiences huge repulsive force, and definitely because it is further from the negative charge, attractive force towards the negative charge. It experiences two forces, because of which I want you to sincerely look at it. From that position, it will now move away from along the radial line, which is basically this direction. It starts moving along this resultant. Correct? It moves along the resultant of these two forces. Let us say it comes to this point. You are continuously following. It experiences the repulsive force of lesser magnitude. You should know that this fellow positive charge, because it is getting repelled from positive charge and attracted from negative charge, continuously moves away from positive charge and towards negative charge. That's what can be seen. This will increase a bit, because of which it tends to move in this direction. It comes to this position. Then it experiences this force, because of which it moves in this direction. But it cannot move till the end in that direction only. From point to point, as soon as it tends to move, it moves in that particular direction for a small distance. The force from positive charge will change, negative charge will change, and then it continuously changes its path. Ultimately reaches the negative charge. if you see the field line going from positive charge to negative charge, the direction of the force experienced by the small test charge at any point on that line is along the tangent drawn to the circle, that tangent drawn to the curve at that point. I think you have to concentrate and see that. Definitely on the line which is the perpendicular bisector of these two, the line joining these two charges, you can directly say whatever the force with which this repels will be same as the force with which it attracts, it gets attracted from towards the negative charge. And the angle is also same, one above and one below. If this is theta and this is theta, its vertical component becomes equal to 0 and the resultant will be horizontal. And it is a peak point on that curve. If I keep it below, it goes like this. At this point, because it moves in a different direction initially. From there, it has to change its path and come back. Like this, so many field lines can be drawn. In which, please see, if these two charges are of same magnitude, the number of flux lines or field lines emitted by positive charge is equal to the number of flux lines or field lines getting terminated on the negative charge. In fact, one charge line goes to infinity, the corresponding line at infinity takes the return path and comes back to the negative charge from infinity. The size of this curve increases, right? Like this, depending upon the position where I start by keeping the positive charge. One good information here. If I consider any imaginary closed surface around positive charge, not including negative charge, Q number of flux lines will leave the closed surface. If I consider a closed surface around negative charge, Q number of flux lines will go into the closed surface and get terminated on the negative charge. If I consider a closed surface containing both positive and negative charges, the total number of flux lines that leave this positive charge will be same as the total number of flux lines that enter the negative surface. Total number of flux lines going out or coming in is 0. One statement is correct here. If you consider an imaginary closed surface, the total number of flux lines that come out of it is equal to the net charge enclosed by it. If net charge is positive, so many will come out. If the net charge is negative, so many will go in effectively. That point is to be really made clear here. I told you that if there is a positive charge of q coulombs of flux lines are generated by it, it's sent to the space. They go till infinity if there is only positive test charge. If there is a negative charge, so many lines appear to come from infinity and get terminated on that charge. But the number of lines is fixed, the amount of charge. If I have a system of charges in which one is positive charge and another is negative charge and their magnitudes are same, all the lines emitted by positive charge will ultimately come onto the negative charge. Nothing will go to infinity. One line, of course, goes to infinity, and again, the same line will come back to the negative charge from infinity. That need not be counted. Next. Okay. Now listen. This is the point. If there is a big positive charge and small negative charge, we expect this to happen. This is one field line, no doubt. If I keep it here, this is another field line, no doubt. I think you understood this. The point where it becomes horizontal is closer to negative charge. This is what, if you can carefully see, you can get this. From this, it comes like this, goes like this. Maybe from this position also it comes back. But these are the positions where it will basically have a effect, but ultimately they go to infinity. They get repelled continuously. They will never come back to negative charge. So many lines will skip and go to infinity. They will not go to the negative charge. True, it is. Correct or no? Positive charge is emitting more lines. Negative charge is terminating lesser number of lines. Means what? The difference between this should go to infinity. And the structure of the field will be like this. Now if I imagine, take a imaginary closed surface enclosing both Q1 minus Q2 in magnitude. Number of lines will leave the surface and go out. Net charge is that actually, if this is positive Q1, this is Q2, negative charge. Q1 minus Q2 number of lines will go out of this closed surface, they diverge away from. Please check. Gauss law, that's how it states actually. Total number of flux lines passing through any imaginary closed surface is equal to the net charge enclosed by the closed surface. If the net charge is 0, if both charges are equal in magnitude, whatever may be the surface that you basically talk about, if it contains both the charges, some lines are generated inside and go to the other charge directly. Some lines which go out of this closed surface will ultimately enter the closed surface and reach the negative charge. Please check. I am speaking about the theory required for us to get into mathematical derivations. And simultaneously, I am introducing the points I had itself, right? When I go to the topic, you will understand. Next. Another system of charges. If there is a positive charge and another positive charge of same magnitude, what will happen? If I leave a charge at the positive charge, it comes till the center and stops. Correct? Ultimately. On the same line, if I keep it here, it comes to the center and stops, because at the center it experiences zero force. It stops there. If I keep the positive charge here, it continuously gets repelled by both. Because of which the structure of the field will be like this. In the same way, at this also they go out, because both are positive charges. The positive charge continuously moves away from both. Maybe you have studied all these things, but it's my duty to actually talk about all these things, because otherwise it is just mathematical subject in which you normally we don't find interest. Having discussed these things, in fact, you will be able to appreciate the subject in a better way while doing the mathematical derivations. These are important things for me. If you want to really understand what gradient is, if you want to really understand what divergence is, if you want to really understand what curl is, you have to come through this procedure. Once I finish this theoretical discussion, everything is mathematical. While taking these statements, I will be doing mathematical derivations. In this particular case, what will happen? Again, it's all going out. If the surface enclosed is Q2, only Q2, Q1 only Q1. If it encloses both, Q1 plus Q2. All are going out only. In the same way, if both are negative charges, all the lines will come in. If they are coming out of a closed surface, we will say diverging out, positive divergence. If they are going into a closed surface, we say converging into negative divergence. If the divergence is negative, they are actually converging. If the divergence is positive, they are actually going out. That happens if positive charge is there inside. Convergence or negative divergence happens if the net charge inside it is negative. I think you will be able to appreciate more. Right here, if the bigger charge is negative charge and smaller charge is positive charge, what will happen? More number of lines will come from infinity. Positive charge emits only small lines which get terminated on the negative charge. But the remaining lines, because on any negative charge of Q coulombs of flux lines should end, should get terminated. The remaining lines should come from infinity like no isolated charge. Please check. No. Check it. Because there is no symmetry in the field structure. In the system of charges case, I cannot use Gauss law to determine, or the flux lines to determine the field intensity. Only if there is a symmetry. This field created by the system of charges has no symmetry. Isolated charges created spherical symmetry, because of which we could use Gauss law to calculate the field. Gauss law is what actually telling that this many lines will come out from the closed surface, depending upon the amount of charge present in it. Listen. I'm talking about few properties of the field lines that we should know. Maybe you know that, you might have studied it also. Field or flux lines. Start on positive charge and terminate on negative charge, I think, and by R infinity, at infinity. Correct, no? They have to get emitted from a positive charge and terminate on negative charge if there is negative charge, equal amount or more. In that case, every line will get terminated on negative charge only. Remaining will go to infinity. If there is no negative charge, all the lines will go to infinity. Flux lines terminate on negative charge coming from infinity some or positive charge. Whichever is terminated may come from infinity if there is lesser amount of positive charge or no positive charge. All the lines will come from infinity. If there is some positive charge, some line will come from positive charge, the remaining line will come from infinity. If there is equal amount of positive charge, every line will come from positive charge and get terminated on negative charge. I think you are appreciating the statements.